Hello, everyone. My name is Muhammed Salih Güler, and I'm an Android and Flutter developer at a company called Kamax Berlin. Kamax Berlin is a mobile development agency that provides some solutions to its clients for mobile or web. And since we are an agency, we are mostly trying to fast and efficient, so we are always looking for some alternatives to do this. And when we were doing this, we came across with Flutter. But what is Flutter? Probably, how many of you heard about Flutter so far? Yeah, some hands, not much. So, Flutter is a mobile development SDK created by Google. It's open source, and it gives you an opportunity to write iOS and Android code from the same workspace. It uses Dart language, and you can play around with it, check out the code, and use it. And most importantly, it's efficient in the graphical performance way. So it uses a special engine called Skia 2D rendering engine. And this engine helps us to have some animations can be running smoother. So when we create the animations, we can have performance like 60 frames per second, and if you have the device, actually it can go up to 120. So we had, at the end, as a company, we had something that we can use for multi-platforms. And what we can also see is it's really open to improvements, and it can be used to have some products in an efficient and beautiful way. So then we started to get some offers and put this in use. And as we go by, I dived into Flutter, and I started to write blog posts about it. And I started with how you can create a Flutter application in a weekend, how to test it. Then I was stuck. I wanted to go to a next approach, next blog post. Then I remembered it was really efficient for the animations. And I said, OK, why not try this? Why not create animations with Flutter? Therefore, I started to go and deep dive about animations and ask myself why animations are important. And the answer to this question is actually really simple. Because we have clients, we have human beings as clients, and human beings are visually driven creatures. So when they do something, they want to see a feedback. They want to see something and understand what's going on really fast. And as developers, we can use this information to create something that actually can tell more than 1,000 words with one simple animation. But your animations should be well thought and tested carefully with your team of UX and UI designers. It should be covering the expectations and narrative. So when you have something with animations, your users shouldn't be thinking that what's going on here, what should I do? It should directly understand that your animation is, for example, if you're putting a loading animation, it should be saying that, OK, this is a loading animation. Or when you click on a button, to a timer, etc., they should know it instantly. It shouldn't give more questions to your users. They don't like it. So I was going more deeper and deeper. Then I came across with this GIF. In this GIF and related to blog post, the UX designers were talking about the basic concepts about the development strategies. And the thing is, these things are widely used in some ways that we can name positioning animations or transforming something, some shape from one to another. And I was like, OK, now I have a point of start, and I have the concept, so I can dive into animations in Flutter. So animations in Flutter goes to two categories. One is called tween animations, and the other one is called physics-based animations. Tween animations are, the tween word is coming from in-betweening. So you have a beginning and an end value, and it goes in between these two values and interpolates it and generates the value that you can use to animate. And the second category is called physics-based animation. Actually, physics-based animations are trying to imitate the physics rules that we learn mostly in school and have some real-life behavior. For example, if you want to have, I don't know, tossing ball animation, you can give the mass, the fraction, the gravity, and according to these values, it will be automatically coming out of the box from Flutter, and with these values, you will have something that you can use, actually. So let's go deeper with tween animations. So this will be our main focus, because when you look at this GIF, I've seen that most of these animations can be done with tween animations. So I was like, okay, these tween animations were more used in our use cases, and I needed something. So I said, okay, I will take the first 6, create something, create these animations, and write a blog post about it. And I said, okay, these are something that I can rely on. And in the meantime, what I've seen is, actually, by changing simply some small amount of code, we can have 6 different animations in one iteration. So that is what we are going to do now. First, we will start with something called easing animation. Okay, so easing animation is, for the easing animation, we have some object coming from the left end of the screen, comes to the center, and it goes to the right end of the screen. And it is like combining 2 animations, and at the end of the second animation, it goes back to the initial screen. So we will be implementing this. But first, we need to have our projects created. For creating a Flutter project, we are simply when we have the SDK in our computer, we are simply writing Flutter create and the animation name, the project name at the end of it. And it gives us a project that we can see some aspects of Flutter, like some widgets, some operational things. And by using this, actually, we can see if our system is working. And with the out-of-the-box things, you can see how Flutter is working a little bit. For the next step for us, what we are going to do here in our app is, we have something called my homepage widget, and we will be getting rid of it, and we will be creating our own widget. And we will be just changing this code in the My app, and we will be saying, let's call this easing animation widget. So after this, how to create a widget, right? So for creating in Flutter, probably the ones that heard knows it, everything is a widget. And all the widgets are immutable. So this means when it's created, you cannot alter it. You need to do something extra for this. Luckily, Flutter people thought about it, and they have created something called stateful widget. The stateful widget itself is immutable. This is true. It doesn't change. But it has something called state. So when you change the state of it, it alerts the parent widget and recreates that, so we can have something more reactive, something more listening our needs. So right now, we have created our stateful widget, we have created a state, but we haven't created our widget yet. And in the animation, we have seen a square box in the center, staying in the center of the screen, and coming from the left, staying in the center of the screen, and leaving from the right. So that's what we are going to have. But first, let's create the square. For creating square, what we are doing is, we are having something called container. Container is more or less like our frame, and we will give a width and height. It will be same because we want to have a square. And for the background, we will give a color, and this color, black 12, means it has some transpiration. So we have created our square now, but it's not in the center of the screen. So what we are going to do here is, we are using a special widget called center, and this center widget, what it's doing is, it gets the child widget and puts it in its center. And last but not least, we will be wrapping all of these to a scaffold. It's not actually super necessary, but worth to mention, scaffold is a special widget to help us to use material design things like toolbar or floating action button or so. And this will be also helping us if you want to have material design animations or etc. So therefore, we have wrapped it up, and we will continue running our app, and we will be seeing that we have some square at the center of the screen after running this code. So our next step is animating this. For animating this, of course, we need something related to animation. So first, we will talk about animation object. Animation object is an object to interpolate some value for your needs. It generates the animation values, but it doesn't have anything to do with the UI. It's not bound to UI. It just gives information. So for bounding this information, for creating the animation, for starting the animation, we need something called animation controller. Animation controller will be giving information about our animation state, and we can alter the animation information or listen to its status or so. So right now we have declared our variables, but we need to learn how to create these values. And for creating these values, what we are going to do here is, for creating an animation object, we will be using something that we heard in the beginning called tween. Tween is a special class. Again, it gets a beginning and end value, nothing different than we learned, and it interpolates between these values. You can change the interpolating way, and in here, we wanted to interpolate between these two values by animating. And for animating, of course, we need to give an animation. So we can give a linear animation, curved animation, or step animation. These are linear animation is something constant. It works constantly. It doesn't change in the meantime. Curved animation is the thing that we will be using mostly. So it will be doing, for example, starting fast, going slow, or going regularly, and in the point, it goes really fast. So for having something non-linear, more interactive, we will be using curved animations. So we have given -1 and 0. In this case, -1 means the left end of the screen, 0 is center, and 1 is the right end of the screen. Right now, and afterwards, we will be creating our controller. Controller is getting a duration value for our animation. And another really important concept here is the vsync parameter that we provide, which is a ticker. Ticker is one of the most important things for animation. So ticker is a special class to notify the animation on each frame change. So when we pass this information with controller to our widget, it will be, normally if we don't do this, it will be creating the whole tree. But when we have this, it will be creating the related widget, so it will be more efficient and more performant, we could say. So right now, after we have this, we would have something coming from left, going to the center, but we haven't bound this to our widget yet. As a logic, it's there, but how do we bound this? For bounding this, first, in our widget method, the build method, we will be using something called animated builder. Animated builder is a special class that gets the information and the status of the animation automatically and renders the transition. But it doesn't know how to render the widget, and it doesn't know about the initial state of the controller. So what it does is we are given a controller and a builder method to create the animated builder. When we give the widget and when we give the controller, it will do the translation for transforming it to values. And for moving it from left to right position, what we are doing here is we are using transform. Transform is, in each frame change, before painting the widget, it gets the information from the animation, this animation value, And it moves it to the related position in each frame change. So we are having this animation by each iteration and each frame change when the ticker is saying that, OK, next frame is ready, next frame is ready. So in each iteration, we are having a movement and then animation at the end. So we have created our animations and stuff, but there's something really important to talk about, dispose. So in each dispose, when the widget is not in the widget tree or when it's not valid anymore, we need to consider to dispose our controller to prevent some unwanted behaviors, I would say. It can be memory leaks, it can lead to crashes, to do something with a widget that is not there anymore. OK, so far, when we run this code so far, we will have the animation that I mentioned coming from left and staying in the center. But it will not be going from center to the right. Normally, we can do chaining the animations in Flutter. But for the sake of showing you the status listener and how you can implement it, I decided to chain the animation by using the status listener. So how do we implement this? We are implementing this by, first, we are simply adding add status listener. So this status listener, when it's added, it will have a callback. It will have a state callback that will be giving us information about the animation. So when it's in the beginning, like 0 position, I would say, it's in the dismissed state. When it's in the 1 position, it will be in the completed state, and so on. For the sake of our animation, we will use the completed one. So for the first animation, if it's completed, what we are going to do here is we will remove the previous status listener and reset the previous controller. And then we will create a new animation from the center to the right end. And we will add another status listener to this. And this status listener will go back to the first initial screen when it's completed by just simply saying navigator.pop context. So when we run this code at the end, we will be having the thing that we want in the beginning. We will have an easing animation. So far, we have covered how to create and how to make an animation. From now on, we will be doing the altering, the changing part for the code. So first of all, we will be doing offset and delay animation. This one is my personal favorite. I use it widely in my applications. For example, when I create a custom floating action button for positioning the sub-elements, I'm using delay. Or like if I'm going to position another object in the screen to have some nice movement, I'm using this. So how do we implement this? What we are going to do here is actually add a new animation called late animation. And this will have one difference between the previous one, only one difference. And this difference is called interval. Interval is, for intervals, animations are starting from 0 to 1 point. And for making latency, for starting from a certain point, you can change the percentage of it according to your needs. For example, let's assume that you have a 10-second animation. And you want this animation to start like 2 seconds later. What you're going to do here is give 0.2 as begin value, and for the end value, you will give 1. So what it's going to do here is doing exactly the same thing, but it will start 2 seconds late, and it will take 8 seconds. So your animation will start 2 seconds later, but it will be 20% faster, I would say. So we have our new animation, but we haven't created our widget yet, because that widget had smaller elements, and we need to create it. For creating that, in the first part, what we're going to do here is make this container smaller and give it a padding so that give it a padding that it will have some gap between the elements. So we will double this and use the previous animation code. It will do the exact same thing that we want. And for the late animation, what we are going to do here is just copy and paste the previous one and actually only change the animation to late animation. And the rest will be happened itself. So when we run this code, we will have the previous one. So again, small changes. We have 3 objects, one with latency. Let's talk about the parenting animation that we have seen. So parenting animation is really useful for like highlighting something or making a composition of transitioning. And in here, what we are having is we have a parent element, and we have a small widget that interpolates itself from a smaller widget to a bigger one and moving it in the meantime. And when the animation ends, it doesn't go to the end of the screen anymore. It reverses itself. So what we are going to see here is, first, before we were using simple values like -1, 0, or 1 for our tween elements, but right now what we are having here is 10 and 100, which are the size values of this element. So first time now, we are changing the size, we will be changing the size of it. And for the starting point, since we wanted to start from the left end, not from the behind of the border, we will be saying, okay, start from 0.25. This is the left-hand border. And last but not least, there is something that we need to cover. So we are having a reverse animation behavior, and it doesn't come with an extra burden. The Flutter is bringing this reverse animation behavior, bringing this animation to its initial state out of the box. So only thing that we need to do here is write controller reverse when it's ready, and at the end, we will be having something, we will be having its own callback, which is dismissed. So, and we will pass the information, of course, to our build method. What we are going to do here is we will delete the third one, uses the late animation. Then we will be having two widgets, and one will be we will be changing the height of it, and it will be 100. And the first one will be using the grooving animation value that we provided from our tween. So in the meantime, it will be doing its change with height and width. And another thing to mention is, so these animations are also moving to the center meanwhile. So it changes its value, it changes its height and width, and it moves. So it means we can control multiple animations with the same controller, with the same ticker, with the same duration, and it will help us to save a lot of code. So we are done with that too. And next one is called transformation and masking animation. Transformation and masking animation is like really cool. I really like this one. And the only difference between these two is masking animation has a frame behind it, and it gives you the feeling that you're having a circle, and it masks itself to to fill the frame behind it. So what we are going to do here is we will do the masking one, and if you want to have the transformation one, only difference is they are stacked, so you can delete the one at the stack, and you can have the transformation one. So how do we implement this? First of all, as we see, it starts as a small circle and goes to a square, a bigger one. So we need to have some values to change its height and width to a bigger position. And another thing that we need to consider is, in the beginning, we have a circle, but at the end, we have a square. So we don't have any border radius anymore. So what we are going to do here is we are going to use a special tween object called border radius tween. We will give the initial give the initial radius to it, and give 0 as the end radius. So it will interpolate the value and give the related value when we need it. And when we're done with this, how do we implement this in our build method anymore? Again, not anymore. And what we are going to have is, first, we will have a width and height, and this width and height will be using the values from our size change animation object. In each animation ticker, in each animation change, it will be changing the width and height of the animation, width and height of the widget. And the second thing is, there is a border radius. There is a border radius element in box decoration. So what we are going to do here is, we will be getting the radius value from the border radius tween, and change the radius in each frame change, each tick. So with this way, we will be having, starting from the circle and going to the square animation by just simply giving the values after we create the tween animations. And last animation that we're going to talk is called value change animation. It's pretty straightforward. It just has a begin and an end value. It starts fast and goes slower to the end. And we will be implementing this, again, pretty straightforward by using tween. We will give a beginning and end value. And this is the beauty of tweens. Like, Flutter comes with a lot of tween objects that you can use to animate stuff. So you can use a color tween to go in between colors. You can use int value to go in between values. You can use the border radius tween, as we saw, and many more. So, and if it's not enough for you, another good thing is when you have a use case that you are using multiple animations in the same project, what you can do is you can create your own tween by extending the tween class, and you can do everything that you want in that tween class. So, but if you go back to this tween, what we are doing here is in each tick we are showing the object in the text, and it is giving us an opportunity to see the values in an animated way. So far we have seen all the 6 concepts, and it took more or less like 20 minutes for us to have 6 animations by iterating each other. And these 6 animations are widely used in multiple scenarios, and it can be asked from your UX or UI designer in any moment. So now we know how to implement this by simply changing some code. Let's talk about physics-based animation, but I will not go deeper as I did in tween, don't worry. So physics animation is, as we said, Flutter is trying to give us an opportunity to use physics rules that we learn in the school, and so we can have some things. So in the Flutter physics class, we can see some friction simulation, gravity simulation, and spring simulation to have something more real, something more from the real life that you can use with the physics animations. What we are going to use will be spring simulation. We will make a spring animation. And this spring animation, we will have something from the top. It will be free-falling. When it goes to the end of the screen, it will be doing the focus law and make a spring. Focus law is a physics law that explains the spring and energy changes. So, since this is a different category, we would be having some different things to create this. So first of all, we would have something called spring description. This spring description is creating the information about the object that will be used to spring animation. So we can give a mass, stiffness, and damping, and this will be combining and changing the behavior and the spring. Let's say spring height is changing according to the information that you make. Or if you give some more stiffness or damping, it will even change the fraction a little bit, so your free falling will be a different one than you do. And we will have a Spring simulation object that will be doing the interpolation. And since these are called animations, of course, we will be having animation controllers. In our animation controller, we will be given, again, a ticker. And most importantly, we will be given a lower bound and upper bound. Lower bound and upper bound will be infinities because since these are physics animations, this will be calculated by the Flutter system and will be happening according to the information that we give. So we don't have to give a duration to it. It will be calculating its duration itself. So when you change like the damping or so, when it gets slower, you cannot rely on or you cannot give a duration to it to make it faster. That's why we are giving here infinity values. So how do we create the Spring simulation and Spring animation? Animation controller, we already created animation controller, and Spring simulation gets the Spring description, and it gets the size of the object that we created, and it is using the low end as the limit. And last but not least, it is using a velocity. You can give a simple velocity that we know from the physics, and what I'm doing here is I'm using the animation control velocity just to have the velocity that I want to have. And the main difference is this animation controller uses a method called animate with. This animate with gets a Spring simulation and starts the animation behavior. And for using it, we are not doing something different. We are not doing something extra. We are just using the value that we have in the transform as we did before. And it will, when it hits to the last position, when it hits to the end position, it's doing the Spring behavior automatic by itself. So, conclusion. Animations are cool. Don't be afraid to use it, especially if it's the case with Flutter. Because Flutter gives us the flexibility and freedom to go through any animation by going simply. And one of the most important things that we see here is these animations looks cool, right? But only difference between these animations and then we created is the designs. For example, first one is using the latency animation, the second one is using the parenting animation, and the last one is using transform animation. So with the design that we have, actually we can have all of these three animations with the code that we had before. So as I said, do not be afraid to use Flutter and tell your UX UI designer to just tell that person that imagination is his or her limit. And Flutter will be taking care of that for sure. So, thank you for listening to me. I really appreciate it for your time. The code is available on GitHub. And I wrote a blog post about it in Medium, so you can check out. And if you have any questions besides today, you can always reach out to me on Twitter with private messages or so, or if you have any suggestions, I'm always open to that. Yeah, again, thank you for listening. Have a nice Saturday.
Yeah, thank you. And now we have some questions from Slido. So where do you find inspiration for new animations?
I mean, I use apps a lot, so I check out most of the apps and see the animations and how do they handle it. I mean, besides, of course, in our company, we have in-house UX UI designers, so she is coming out with some stuff, but mostly I'm using the apps and seeing the animation and using it. Or like I'm following the blog posts and see how people handle these situations, and this is how I implement these and find the inspiration, I would say.
Okay. And another, is possible to debug an animation?
Yes, it is. It's possible to debug everything, actually. And I mean, by animation, if you can see the value, yeah, in each frame tick, in each frame change, if you put a debug breakpoint, you can animate and see the value changes with your, I'm using IntelliJ IDEA, or Android Studio, you can see it easily.
So, and another, are there any solid libraries that provide out-of-the-box animations?
Yeah, like, for example, Flutter has a lot of classes and widgets that you can use to animate. Like if you want to have a page transition animation, Flutter comes with something called hero animations. And community is really active about it. So they are creating some animations most of the time. And if you go to the, if you check out the Flutter documentation, or if you go through GitHub or follow the Flutter communities, in Twitter there are some pages like Flutter Community, Flutter Weekly or so. People are doing this stuff really often, so you can see how they are doing it, and they mostly have tendency to create some plugins for those. So you can do this with those plugins too.
Okay, and the last one, have you noticed any drop in performance when using animations?
Yes and no. Yes is, with the tween, I haven't seen anything. I have tested most of the animations in really, really low-end devices, like Samsung. I started from Samsung S4 and come to the Google Pixel 2. And performance-wise, it's really efficient. That is why I'm 99.9% sure that it won't have any flakiness. And it didn't have anything in my case. But for the physics-based animation, I already talked this with some people from Flutter, I would say. There was one small issue. When you try to change something in the screen, sometimes it can be a bit flaky to use the physics-based animation. But yeah, in most of the cases, we don't use it. We mostly use in tween, and tween is super efficient and easy to implement, I would say.
So thanks. That's all.
Thank you.